the aneurysm develops. And so what we plan for the future, as we look for the biomarkers for the Marfan patients, is we can also adapt some of the work to make an impact on patients with bicuspid aortic valve disease. And the importance again is to be able to predict which of those patients will run into trouble in their lifetime and which of those patients won't. Because it's not enough to turn around and say, well, listen, everybody in the room here, I would say, about 4 out of every 10 here probably have a bicuspid aortic valve. Does it matter? No, because you're all sitting here and you're all well. But if we were to find out about it, we would develop a test to say, well, it does matter to this group, it doesn't matter to that group. And so that's where our research should be focused, along with the work on the Marfan syndrome. And so that'll give you an idea of where we're headed. And so Geraldine had made a suggestion that we broaden the scope of the research, and so that's where we would like to see the research go. Maintaining our complete focus, of course, on Marfan syndrome, but using and learning from what we've gained from the experience and research in Marfans, apply it to what turns out to be a very common condition that's been increasingly recognized as a serious issue for certain patients, as I say, with bicuspid aortic valve disease. So I'm going to finish there, and then John is going to, who made his way down here. He has the slowest car of the three of us, obviously.
Well, as I was driving at 20 miles an hour down the Nace Road, I eventually came upon a 4-car pileup, which explained why traffic is so bad. So I like this quote. It's about a famous musician and composer about 100 years ago. Schoenberg said of this man, he was brave, stately, tall and unsmiling, and he walked quietly to the piano. And he was talking about this young composer. This is about 100 years ago. I don't expect anyone except the most avid classical music fans to recognize him from the photo. He was an excellent composer and he was a great musician, and in part that was probably helped by his enormous hands. His reach on the piano was much greater than the normal individual. So that was Sergei Rachmaninoff. Anyone that's seen the music Shine would have heard a lot of the music that runs through that was composed by Rachmaninoff. And as is often custom amongst classical composers, they will often take a theme from a previous composer, turn it around, turn it on its head, and make an entirely new composition. And Rachmaninoff's probably his second most famous composition is called Rhapsody on a Theme by Paganini. And Paganini, I'm sure people have heard of him. He was a famous violinist and composer, and he lived about 200 years before Rachmaninoff. And in addition to being to having in common with Rachmaninoff that he was a great musician and composer, it's also thought that he had Marfan syndrome as well. There are a number of other famous people down through the ages who thought they suffered from Marfan syndrome as well. Going back as far as Julius Caesar, the President Abraham Lincoln, and a famous American athlete who passed away of Marfan syndrome, Flo Hyman. So the name Marfan syndrome, it goes back to the presentation, a case report at a medical conference in the late 1800s. And a physician called Antoine Bernard Marfan presented the case of this young girl called Gabrielle P. She was 6 years old, and he noticed that she had very long limbs. And he was probably the first to identify this inherited connective tissue disorder. So that's an image of Antoine Bernard Marfan. Now, when we talk about Marfan syndrome, we call it a genetic multi-system connective tissue disorder. That sounds very complicated, but I'll go through each one of these in turn. So what do we mean when we say it's genetic? Well, going back to basics, DNA is the blueprint for a human being. Every cell in our body contains a code called DNA, which contains the instructions to build a human. This is the double helix. I'm sure everyone has seen photos of this before. And this is what DNA is, and it's a code. And DNA isn't just randomly, it doesn't appear randomly in our cells. There are sections of the DNA which we would call genes, and genes are the individual recipes for individual traits that we all carry. For example, eye colour, hair colour, how tall you might be, etc. And the DNA itself is packaged neatly into what we call chromosomes. And every cell in our human body contains 46 chromosomes, or 23 pairs. So when we say Marfan syndrome is a genetic condition, what we mean is that on chromosome number 15, there's a misspelling in one of the genes. So every cell in the body contains this misspelling. And what that means is that an individual with Marfan syndrome has a 50% chance of passing it on to their offspring. That individual that suffers from Marfan syndrome may have inherited from their parents, or the misspelling, the mutation may have occurred in utero when the egg is fertilized. I'll jump to the third point then. What do we mean when we say connective tissue? Connective tissue is the glue that holds us together. One way to think of it is if you build a house, the house is made of bricks, and the cement and the mortar holds it together. So that's what the connective tissue is. In Marfan syndrome, there's a deficiency in a particular type of connective tissue called fibrillin 1. Because connective tissue is present in most of the organs of the body, it means it's multi-system. So we find abnormalities in different organs of the body. So in the eyes, we see lens dislocation. In the musculoskeletal syndrome, people are excessively tall. They may have very long fingers. They may have an abnormal curvature of the spine. But most importantly, as you've heard about already, are the cardiac abnormalities, which occur in 90% of patients with Marfan syndrome. So how do aneurysms develop? I'm sure Darren has touched on this already, but fortunately, due to the pile-up, I missed that, so I'll go over this again. Arteries are the pipes that carry blood around the body. And all the arteries are made up of three layers: an inner layer, a middle layer, and an outer layer. And in Marfan syndrome, in the middle layer is where we would find that connective tissue, the fibrillin 1 that I mentioned. So in Marfan syndrome, because there's less fibrillin 1, as you might imagine, the artery isn't as strong, and it cannot withstand the pressure of the blood. And therefore, the blood vessel thins and stretches out and turns into an aneurysm. The artery in the body that has the most amount of fibrillin 1 is the aorta, the largest artery in the body. It's the artery that carries all the blood out of the heart. And because it normally has the most amount of fibrillin 1, when there's a lower amount of fibrillin 1, automatically then that means that it's the artery that's going to be most affected. So on the left here, just to show you, this is the heart here. This is the aorta, which is the main artery which carries blood out of the body. And this is a normal size here. And Marfan syndrome then, because it's weak, due to the pressure of blood, it stretches out and becomes an aneurysm. So because Marfan syndrome is a multi-system disorder, that means current treatment is what we call multidisciplinary. So there isn't a single Marfan specialist, but more that it's a team of specialists that will look after someone that has Marfan syndrome. So the family doctor that will coordinate between the different specialties often. A cardiologist who will be involved in monitoring the heart. If it comes to surgery and involved in making the decision to operate, will be the cardiac surgeon, orthopedic surgeon for the skeletal problems, and obviously physiotherapy will play an important role. So the current treatment, regular scans, this is an echocardiograph, we call it, it's a scan of the heart. And if you remember that picture that Professor Redmond showed of the aortic valve with the three leaflets, you might just appreciate the similar picture here, and that's the aorta in cross section. So regular scans are done to monitor the size of the aneurysm.